Hello, one more time. This time, what we're going to do is we're going to do some of the questions about the mass spectra and the percentage of different isotopes that do not involve the actual spectrum, some that might require some calculation. Although a lot of them are really easy to estimate, so you don't need to calculate. But I do want to show you a couple of things. Again, bear in mind that I gave you a practice on your Forge Moodle, and some of these questions might be in there. That's on purpose because I want to show you how it's done. So let's check it out. Uh, this one, for example, this is not a bad website, uh, although it's simpler than it should be for AP, but it's fine. Let's find a nice, easy question. Okay, check this one out. A certain element X is comprised of isotopes A, B, and C. Isotope A has a mass of 50 AMU and is 70% of natural occurring X. Isotope B is 35 and is 25. Okay, this is too long, so I have to write it down. So let's see. So we got three isotopes. Isotope A, sorry, isotope B, and isotope C. So A has a mass of 50 AMU, sorry, and is present at 70%. Okay, and then B is 35 AMU, right? Just copy this and present at 25%, right? And then C has a mass of 70 and is present at 5%. And the question is how to calculate the atomic weight. We did this, although I like to do it again. So again, I don't like this. I like fractions. So 70% is 0.7, 25% is 0.25, 5% is 0.05, and then the mass of X, or the average atomic mass, is 50 times 0.7 plus 35 times 0.25 plus, what is this, 70 times 0.08. Sorry about that. 0.05. And that's how you calculate the mass, the average mass of this element. And you can see that same thing here. They calculate the same way as I do, and you can see the result is AMU, or grams per mole. So let's see this one. I want to see the correct answer if possible. The average molecular weight of for element X is 59.97. So now we basically got the opposite set of data. There are two known isotopes, X, one weighting 59 and other 56. What is the relative abundance of each other? This requires a little bit of math. It's more like a IQ test, and I know you guys are good in this, so we'll just write it down. So the molecular weight of this element is, so the molecular weight is 59.97. So 59.97 is the weight of X, right? Oh, looks like my tuna has arrived. Please ignore that. So there are two isotopes, and one is 59, one is 61. So you've got, see here, this is what I told you. X59 is one isotope, and X61 is the other. So one isotope has a mass 59, the other one has mass of 61. So let's write this down. So you got X59 and X61 here. So how much of this is present. Let's call that, I don't know, Z percent of this, and Y percent of this is present. So basically, we need to average out these two, and together they become 59. So we can just do the reverse thing of what we did before. So we got to go 59.97 equals a fraction of this. Let's say Z would be a fraction, not a percentage. So Z multiplied by 59 plus Y multiplied by 61. So we've got one equation with two unknowns, so we need another equation with those same two unknowns. That's very easy because the fractions, when they add up to 1. So basically, out of these two equations, we can calculate this very easily, and you will get the same result like our friends here. Let's see, yes, so see, they calculated in the same way. So this is what you get when you switch this in here. I don't want to get into that because frankly you guys are better at math than me for sure. Okay, let's find another. Hey, this is a simple and interesting one. Arbitrary element X has two isotopes, X with the mass number 7 and X with the mass number 9. The mass listed on the periodic table is 8 grams per mole. Without doing any calculations, which isotope is more abundant? Well, if the average is 8 and one is 7, one is 9, that means you've got two of them 50-50. So the fractions are 0.5 to 0.5. The percentage is 50% to 50%. So they're present in equal amounts. So it's that. Yep. Let's find something long and difficult. I mean, there are no difficult things here, just long ones. Wait, let's see. This is something we did. Okay. Not very difficult. So, let's see. Okay, this one is interesting. Why? Because this one can be estimated, but it can also be calculated. Kind of. Watch this. The mass spectrum for an unknown element is shown here. According to the information in the spectrum, the atomic mass of the unknown element is closest to. So now they don't want us to figure out which element. They want us to figure out what is the atomic mass closest to. How can I do this? Well, I could basically take each of these peaks, because I see that this has 5 isotopes. I could take each of these peaks and be precise enough to calculate, to read the percentage from this graph. So I would say, okay, 90 has 53%. So I'll go 90 multiplied by 0.53. And then I'll go 91 multiplied by, what is this? 12%, so 0.12. And when I add them together, I could calculate them, the whole mass. But let's try to do it without calculation, because you always want to be quick when you're doing these. You want to teach your mind to kind of work that way. So I've got these here. And if I look at this, I can see that this peak is probably, I mean, it must be bigger than all these combined, because this is 50%. This is percent abundance. So that means 50% is on this side. However, you have 96 here, we have 94, we have 92. So the average is probably here, closer to here. However, here we got 91 and 93. I would say this is 91, but there's also an option of 93, which is here. Here. Probably not correct, but could be. So let's just check the periodic table, because you always got that option. 91, 91, 91, 91. Right? 91.2 and 92.9. So in this case, for example, you should calculate, because Those are both good options. 91.2 would be here. It's a good option. It's possible. And then you've got the other option, which is 92.9, 93. No, this is not possible. See, if it's here, it won't be correct. There's just too much stuff, too little stuff on this side and too much stuff on this side. So this for sure is 91. Let's see if I'm wrong. B, woo, I'm correct. Okay, so you guys got this. There are gonna be many questions which are not gonna be like this. There are too many variations here, and especially for AP type testing, they're going to try to confuse you with the question. But trust me, by watching these couple of videos, you have the knowledge to solve all these. Just calmly consider and ask me questions if you need to. Okay, I have to go get my fish or it's gonna be a catastrophe with cats. See you later.